Hi, this is Sung. I'm your online maths mentor, and now what we're going to be doing is launching straight into the first of the two methods which I talked about. So remember how I said that when we're approximating the root of a polynomial or of a function, we basically have two methods of doing that. The first method is either halving the interval. The second method is Newton's method. We're actually going to use the halving the interval method, right? And so halving the interval method, that method, it's oftentimes known as the bisection method, and the question that we're going to look at calls it the bisection method, right? And basically with the bisection method or the halving the interval method, it basically follows this principle, right? And the principle is this: if for y is equal to f of x, if for a function f of a and f of b are two totally different signs, one being positive, the other one being negative, then what that means, have opposite signs, then there must be at least one root between a and b. So in other words, if one part of the function starts above and the other part of the function starts below, all right, or the value of one function is above, the other function is below, then basically what's going on is at some point it's got to cross over from above to go to below. Does that make sense? It's got to go from above to go to below. So I'll give you an example of what I mean. Just say we've got a function and one part of the function is above. Just say there. Another part of the function is below, right? Above the x-axis, below the x-axis. Then what's going on is at some point the function has to cross over to get to this point here. Does that make sense? And that's what we're looking for, all right? And so the halving the interval method means halving the gap between this point and this point, halving it, working out where the middle is, right? And then working out which half the root is going to be. Is it going to be in this half or is it going to be in this half? And once you've worked out that root, what you can do is find a better approximation by finding that half, the half of that, and working out which half it's going to be inside. Is the root going to be inside this half or is it going to be inside that half? And you can keep doing that until you work out where the root is going to be. Does that make sense? Well, you can keep going forever. Sometimes it won't allow you to go forever, but each time you do it, you're going to get closer and closer to where the real root is going to be, right? So that is basically how to do the bisection method, okay? And I'll show you how to solve it and to do it for a particular example. But let's turn our attention now to the 5-step method of how to halve the interval, okay? Now, this is a method that you can just kind of follow to kind of help you out. First thing is determine your 2 points. Where are the 2 points that you're going to start with, where one point is above and the other point is below, right? Where is that, okay? So you determine your 2 points, right? After you determine your 2 points, the next thing you can do is work out where the midpoint is. So if one point is at A, the other point's at B, your midpoint that you're going to test, in other words, that's the point that halves the interval into two separate sections, that's going to be the midpoint. So you work that out. After you work out the midpoint, you basically ask yourself, is the root at the midpoint? Is at the midpoint where the function crosses the x-axis? Yes or no? If not, then you go to step 4. Determine the half, okay? Which half of the interval? Is it the bottom half or the top half? Or is it the first half or the second half that the root's going to lie in? And the way you can tell is the root is going to lie in, right, the half where one part of the interval and the midpoint are going to be opposite signs. Yes? Where one's positive and the other one's negative, and the one's negative and the other one's positive. Yes? All right, so that's going to be where the midpoint's going to be. That's where the root's going to be, in that interval, in that space, all right? And then you repeat, okay? So you then find the halfway between that half, yeah? And then you go back to step 3 and you repeat until you get closer and closer and closer, or the gap between the 2 points and the midpoint and the root gets smaller and smaller. Does that make sense? Yeah, so I don't even know if I said that right because I was a bit, because I was thinking while I was talking, but anyway, you get the drift, all right? So the best way to do it is not for me to just sit here and rant. The best way to work this out is for me to do an example, all right? So let's do an example on the board. Show that x cubed plus x squared minus 2x minus 9 has roots between, or has a root between 2, x equals to 2 and x equals to 3. Use the bisection method. See how it's called the bisection method and not the halving the interval method? You can use one or the other, okay? But just recognize the two words, the two expressions that they can use for this particular method. So it says use the bisection method twice to approximate the roots, okay? So, first application, we just write first application. So the first application of the bisection method requires us to substitute 2 in. All right, so let's find f of 2. It's going to be 2 cubed plus 2 squared minus 2 lots of 2 minus 9. So let's work that out. So what we've got here is 8 equals to 8 plus 4 minus 9 equals to minus 1. Does that make sense? And then we're going to do f of 3. Okay, so let's work that out. F of 3 is equal to 3 cubed plus 3 squared minus 2 lots of 3 minus 9, which gives us 27 plus 9 minus 6 minus 9 gives you 21. Is that right? 9 and 9 cancel. 27 minus 6 is 21. Yes, good. So the root is going to lie between F2 and F3. Yes? Good. So let's just write that down. So root will be between F2 and F3, which, when we graph that, looks like this. So if you've got 2 here and 3 there, I know this is not to scale, all right, but just say you've got 2 there and 3 there, that's y, and that's x, and you've got minus 1 here, and plus 27 there, your root's going to be somewhere in between 2 and 3, yes? All right? So, consider midpoint. 2 plus 3 over 2 equals 2.5. Does that make sense? All right. So you go f of x, f of 2.5 is equal to 2.5 to the power of 3 minus 2.5 squared, so plus 2.5 squared, minus 2 lots of 2.5 minus 9. So you work that out on your calculator. So I've got my calculator here, so we're going to work this out, okay, because that's substituting 2.5 into that function, yes? So let's work that out, and that gives me 7.875. Does that make sense? Okay, now 7.875 for 2.5 means that 2.5, which is over here, is going to be positive. Yes? So if you've got 1 point, f of 2 being down here, f of 2.5 being there, f of 3 being up here, where does that suggest your root is going to be? So let's join the dots. If we join the dots between there and there, the root's going to lie, in other words, this line is going to cross between 2 and 2.5. Can you see that? And can you see that the line between 2.5 and 3 is not where it's going to cross? If you join that line, it's not going to cross with this line, yes? So therefore, the root will be between f2, well, not f2, x is equal to 2 and x is equal to 2.5. Does that make sense? Yeah. So that's the first application of the bisection method. The second application of the bisection method is what we're going to be doing now. So we worked out that the root will be between x equals to 2 and x equals to 2.5. F of 2 is equal to -1. And f of 2.5 is equal to, what is it? 7.875. Does that make sense? So what we've got to do is we've got to work out the halfway point or the midpoint between 2 and 2.5. Does that make sense? So consider the midpoint x, the midpoint 2 plus 2.5 is 4.5, and half of that is 2.25, right? X equals to 2.25. Yep. So let's work that out, all right? F of 2.25 is going to be, all right, let me stand around this side so I can work it out. So let's work this out, shall we? Okay. I've got my trusty calculator. So we're going to work this out. So basically what we've got is 2.25 to the power of 3 plus 2.25 squared minus 2 times 2.25, which is 4.5, minus 9. Let's work that out. And the answer is 2.95325, right? Which again, that answer is going to be above the x-axis as well. So 2.2.5, which is there, is going to be above the x-axis as well. So what does that tell you about where the root is? The root is going to be between 2 and 2.5. Does that make sense? Because that's where it's going to cross. All these other places are not going to cross. Yes? So somehow the polynomial or the function is going to go from there, and it's going to cross somewhere between 2 and 2.5. And see how we're narrowing the interval each time? So we narrowed the interval from 2 to 3, okay, from 2 to 3 to become 2 to 2.5. And now what we've done with the second application, we've narrowed the interval from 2 to 2.5 to 2 to 2.25. Does that make sense? So each time we're narrowing the interval, and what that does is it helps us to find a shorter and shorter range where the root might be in, okay? So from there, we can determine, therefore, the root will be between x equals to 2 and x is equal to 2.25. Does that make sense? See how the root will be between 2 and 2.25? Yep. And that was all worked out because we used the bisection method or halving the interval method. We used it twice. Yep. If we use it a third time, we can get even more closer to the to where the root actually is, right? And we can narrow down the gap, all right, as much as we want to help us find where the root's going to be. So that is basically how we use the bisection method. In the next episode, I'm going to be showing you another method which is probably a little bit more efficient than halving the interval, and that is Newton's method. Thanks for watching. Bye.